Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Slices of Tentropy, and it's by Matt Tressel in Sudoku. And here are the rules. Normal Sudoku rules apply. That is, each row, we can get a row, column, and 3 by 3 region has to contain the digits from 1 to 9 once each. Each line in the grid is both a tentropy and an equal split line. So the rules for tentropy lines are every set of 4 adjacent digits, those might cross dots, on a hollow peach line must contain a digit from each of the x pairs or 10 pair subsets of 1 through 9, 1 and 9, 2 and 8, 3 and 7, and 4 and 6. A 5 may not appear on a tentropy line, and digits on a line may repeat if allowed by other rules. So you could have as an example something like, I don't know, 7 to 9, 6. This would work as a valid 4 adjacent digits on a tentropy line, because you have 1, that's 7, which is from 3 and 7, 2 is from 2 and 8, 9 is from 1 and 9, and 6 is from 4 and 6. So you have one of each of the different pairs that add up to 10, essentially, which is why they're called 10 pairs here. And that's what tentropy lines must be. We also have equal split lines, where dots split peach lines into segments with equal sums. Digits may repeat on lines, but not within a segment. Different lines may have different sums. For example, let's see if we have, I don't see one that's possible. Okay, let's say this was just 4 digits here. But for example, a valid equal split line could read 1, 2, 3, 4. Okay, that's not gonna work, but something like 1, 2, 3, 4, 1, 2, 7. Because these 3 digits add up to 10, and these 4 digits would add up to 10 also. So therefore, they add up to each other and form a valid sum in each place. Obviously, this would break because of normal Sudoku rules. But that's the theory behind equal split lines, is that the dot separates the line into segments of equal value, or that sum to equal value, and you cannot have repeats within any singular segment. But you can have repeats along the line. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first thing I see is we have 6 digits here adding up to the same as what 3 unique digits add up to. Again, there are no repeats within a segment, so therefore this is at minimum, and in addition, this is a tentropy line. So in addition to being an equal split line, it's a tentropy line, which means there are no 5s along it. So actually in row 1, where are the 5s? They have to be here. So this is a 5. One of these two is a 5. Therefore, in the rest of this box, there cannot be a 5. Where in column 1 is there a 5? It can't be on the tentropy line, so it must be here. So this is a 5. But the point is, on the tentropy line, what is the minimum value for 6 digits, right? It's 1, 2, 3, 4, 6, 7. It cannot be 1, 2, 3, 4, 5, 6, because you can't have a 5 on a tentropy line. So 1, 2, 3, 4, 6, 7 adds up to 23. So this is either 1, 2, 3, 4, 6, 7, or it's 1, 2, 3, 4, 6, 8, adding up to 24. because these 3 unique digits must either be 23 or 24. Because you can have 789 at max, and then you can have 689 as possibilities. Either way, 8 and 9 both have to be here, and it's with 6 or 7 here, right? So because of that, one of these is 9, one of these is 8, which means along this set of digits, one of these must be 1, and then the other one must be 2, right? Because we know there's a 1 and a 2, there's a 1, 2, 3, 4 in this set here, right? So if this is 7, 8, 9, this is 1, 2, 3, 4, 6, 8. If it's 6, 8, 9, it's 1, 2, 3, 4, 6, 7. So what does that mean? So we know the 9's one of these 3 digits. In every 4 set, you can change to the next one. So if the 9 has to be here and the 8 has to be here, which means in this set, it could be 1, 2, or 8 actually along this. But this one can never be 8 because, and therefore, what do we have here? This is 9 and 8 at least. It could be 6 or 7 here. If this is 6, that means we have 1, 2, 3, 4, 6, 7. So if this is 6, 8, 9, right? This adds up to 23. We need 1, 2, 3, 4, 6, 7. 6 cannot be here. 6 cannot be here either. So 6 has to be one of these 2 digits here. To add up to... Therefore, that matches what 6 is here, right? So 6 would be one of these 2, which would match one of these 2. This is 6, 8, and 9. This must be 3 or 7 then. So that's 3 or 7. Then you'd have 1 and 2 along this, right? Because those are the only subsets from... Those are the only digits from the subsets 1, 9, and 2, 8, which require for these 3 digits. And then this would have to be 4 with 3 or 7 here. So this would be the combination there. Actually, this would have to be the other 3 or 7 here. And then this would be 4, right? So if this is 6, 8, 9, this would be 4. This wouldn't match this one because that's 4 away along the Tentropy line. So this is 3 and 7. This would be 4, which would force this to be the 6, which would make this not... This would have to then be 6 here. So this would be 6. This would be 4. We'd have 3, 7, 1, 2, 1, 2. Right? And the 1 and 2 match the 8 and 9. And then the 3 and 7 would match each other. So this is what it would look like for 6, 8, and 9, adding up to 1, 2, 3, 4, 6, 7. If we had 7, 8, and 9, we would have 1, 2, 3, 4, 6, 8. So the 8 would have to be one of these. This would be 7, 8, 9. This would then have to be... 8 would have to be one of these 2. So 8 would have to be here or here. This would be 4 and 6. Because you'd have 1, 2, 3, 4, 6, and 8 adding up to 24. So this would be 4, 6. This would be 4, 6. 8 would have to be one of these. And then you'd have 1, 3 here. And then this would have to be 2. Because that's the only digit remaining. So this would be 2, which would make this... Okay, so... Then in that case, since this is 2, this is 4, 6, 4, 6. This would have to be 8 here. because 1, 2, 3, 4, 8. So that's 4 digits. Then it's a 2, 8, one from the 2, 8 pair. Then this would be 8, this would be 7, this would be 9, and this would be 1 and 3. So these are the possibilities. 1 then definitely has to be here. We have 8 and 9 definitely here. We're not sure which. 9 is definitely here. So this digit cannot be 8 or 9, cannot be 1 or 2, because on this Tentropy line, the 2 is either one of these two digits or it's here. So it cannot be 8, 9, cannot be 1 or 2. So this is 3, 4, 5, 6, 7 here, because it sees the 8 and 9 here, it sees the 1 here, and it sees the 2 being one of these 3 digits. So this digit is always the same as this digit. Okay. And then must be the same set as this digit. But obviously it's different digits. This matches here. This obviously matches here. And this one matches this one. So we have 4 digits here. So we have 2 orange digits here, which match the Tentropy pole. These 3 that cannot be orange. So orange has to be these 2 digits here. Whatever matches this set, right? Because these 3 cannot be any of the orange. This matches here, this matches here. This is 2 digits at least. This is 5 digits at least. And there must be a 1 here. There must be a 2 and a 3 here too. If the oranges are the 1, this would then have to be 9, which means this is at minimum 19, which 2 unique digits can never add up to. So the oranges cannot be 1, which means, and this can't be following 9, so this has to be 1, which makes this a 9. Therefore, the 1 has to be here. The only combination actually that can work here is 3 and 7. 2 and 8 doesn't work either, because again, this matches up to at most 17. And then 3 and 7 with 1, 2, and 4 here adds up to 17, which is the maximum this could add up to. But it's required because these two add up to 10. Right? So 10, and it cannot be 4 and 6. We know that specifically because of how we derided this equal split line. So this then has to be 3, 7 pair, which forces this to be a 1, 2, 4 triplet. Therefore, this is 3, this is 7, which makes this an 8, that an 8, and this is a 2. This then must be 4 and 6. This is 4 and 6 to add up to 24 here. This can no longer be 3 or 7. It's 4, 5, or 6 here. This can't be 1 because of the 1, 2, 4 triplet in the row. Where is the 1 in box 2? It has to be here. So this is 1. This can't be 4. It's 5 or 6 here. This is 3, 7. These 2 digits must add up to 17. So this must be 8 and 9. Because these are both 8 and 9, they match with 1 and 2 as a pair. So this cannot be 1 or 2. This is a 4. This can't be 4. This is a 1, 2 pair here. So 1 has to be one of these digits here. We have, what are the remaining digits? Are 1, 2, 3, 4, and 6 as possibilities. And this is 2, 3, 4, 5, 6 here. This cannot be green. So the green has to be one of these three. We're not sure which. This is the yellow. What are the remaining digits in column 7? We have 2, 4, 5, 6, and 9. This cannot be 5, though. 2, 4, 5, 6, and 9, but this can't be 9 because of the 8, 9 pair in the box. The rest of box 9 is 1, 2, 4, 5, 6. And this can't be 4. That's all we know. So these two match. We'll match these. And these two match, but we're not sure which one's which. So this digit matches this digit set-wise. So if it's 2, this can't be 2, so this would have to be 8 if that's the case. If this is 9, if this is 4 and 6, it would match the 4 and 6 here. But this can't be 4 because of the 4 in the box, so this can only be 6, but that could match either one here. So that's fine. If this is 9, this would have to be 1 or 9. But it can't be 1 because of the 1, 2 pair in the box, and it can't be 9, so this can never be 9. So this is 2 or 4 or 6. We're not sure which. This can't be 3 or 7. We need a 3 or 7 in one of these two digits here. The remaining digits in column 6 are 5, 6, 8, and 9. But this can't be 5. If this is 9, actually it doesn't have any matching stuff, so this is 6, 8, or 9. That's all we know. This cannot be 6 and 6 here. If this is 6 and this is 6, that eliminates both of these from being a 6. But again, you can't have repeats within the same segment. So therefore, this one of these is 4 and one of these is 6. So this can never be 6. This has to be 2 or 4 here. So 2 or 4 with 6, 8, or 9. That's interesting. One is one of these digits here. We're not sure which. 2 has to be one of these 3 digits there. This, I'm not sure. If this is not, okay, so 9 is one of these 3 digits, actually. If this is 9, it can never be with 1 here to add up to 10. So if this is 9, this has to be 3 at least, because it can't be 2, it can't be 1, because the Tentropy rule set prohibits the 9 and 1 from being next to each other on a Tentropy line, because they're the same subset. So if this is 9, this would have to be 3, 2, which would make this 6 and this 8. That could work, right? 9 plus 3 plus 2 is 14. 6 and 8 add up to 14. So if this is 9, that forces this to be 3. Nine, 3, 2, which would force this to be 6 and this 8. And that works. If this is 8, this would then have to be 4, and this would be 6. This would be 8, 4, and then this could be 1. This would be 6, this would be 7, and that works. So that's if this is 8. If this is 8, that forces this not to be a 2. And therefore, this could be 1. This would be 7, and this would be 6, because it has to be part of the 4, 6 pair. So that works. If this is 6, this then becomes a 2, which makes this 8. I don't think that works. Right, it doesn't work. If this is 6, that forces this to be 2, which forces this to be 8. And then 6 and 2 add up to 8. And 8 also adds up to 8. And then these two digits would have to be the exact same digit, which would break normal Sudoku rules. So this cannot be 6 here. This is 8 or 9. This is 2 or 4. This is 1 or 3. So this can never be 1 here. So one of these is a 6 no matter what. Which means this can't be 6. So this must be 4, which makes this a 6 here. This 4 means this can't be 4. One of these is a 6 again. This is 4, this is 6. So this cannot be 6 here. This cannot be 6 here. The 2 has to be one of these 3 digits. What can these digits be? It cannot be 1, 3, or 4. It could be 2, 6, 7, 8, and 9. And that could correspond to... Okay, cannot be 2 specifically here. No, yeah, the 2 does have to be one of these. So this can't be 2. This can't be 2. This could correspond to 6, 7, 8, and 9 here. Because the point is that one of the 2, 8 pair has to be in one of these 4 digits. Well, 8 can't be here, so the 2 has to be here, and it can't be here. So one of the 2's has to be here. One thing this cannot be is this cannot be 1, 2, 3, or 4. The reason why we know that is if it's 1 through 4, that means we have a 1, 2, 3, 4 quadruplet in this segment, which means it must add up to 10. And these two digits cannot be part of the same 10 pair, which it would have to be because it's 2 digits adding up to 10. So this cannot be 1, 2, 3, or 4. It has to be then 6, 7, or 9 here. Cannot be... Can it be 9? 1, 2, 3, and 9 actually does work, so that could be potentially feasible. We do know there's a 2 here. We know there's a 1 here. So it's either 1, 2, 3 or 1, 2, 4. We're not sure which. Do we have anything else here? these two digits add up to the same as these two digits, and therefore they can't be 17 or 16, right? If it's 17 or 16, only two unique digits can ever add up to those sums. It's either 8, 9 or 7, 9. But we have three digits which are supposed to add up to that sum. So that doesn't work. So this is at most 15 here, which means this is at most 15. Again, it cannot add up to 10, so it cannot be specifically 1, 2, 3, 4 here. Okay, we can remove this coloring because we actually already have all those digits. Same here. What about this? Let's go mark yellow, red, green, and then we're going to make that blue. So this is yellow, red, green, and blue. Oh, interesting. Interesting. Okay, so this cannot be the 3, 7 pair because it's seen by the 3 and the 7 here. So this is either 1, 9, 2, 8, 4, 6. We're not sure which. So it could be 1, 9, 2, 8, or 4, 6 here for the blue. I don't think this can ever be 9, right? If this is 9, can this ever be the higher one? Possibly 6. But if this is 9 and this is 1, this is at most 1, 8, so that adds up to 9 already. And that's 9 by itself with 3 other digits. So that's not going to work. So if it's 1, 9, this is 1, this is 9. It could be same thing with 8 and 2, right? This could be 2, 9 to add up to 11. But then you have 8 here with 3 other unique digits, which is 1, 3, and 4 at minimum. So 2 and 9 add up to 11. 1, 3, 4, 8 adds up to, at minimum, 16. So that's not going to work. So this has to be then 2 and 8 here. But I think 6 could be here, right? If this is 6 and 4, you could have 1, 2, 3, 6, and then 4, 8 here. So yeah, that could work. So this is 4 and 6 here. Okay. The green cannot be the same as the dark cell, but that doesn't really tell us much. Okay, what are the possible combinations here? 1, 2, 3, and 6, adding up to 12. So then this would be 1, 2, 3, 6. You cannot have a 4 here then. So 1, 2, 3, and 6. Okay, so those are the possibilities. 6. This could not be 6. It could not be 8 because you can't have a 4. You can't have a 5 on here, so it would have to be 9 and 3 here. Therefore, the 9 would match with the 1 here. The 3 would have to match with the 3, which is not allowed. Because it's the 3-7 set, but neither of these could be 7. So that doesn't work. Oh, right. Huh. So this cannot be 6 here. Oh, 1 has to be here, so this can never be 9. So now we know exactly what this is. This is 7, which eliminates 3 from the rest of the digits on this segment, right? Because it has to be from 4 digits from 1 from each of the subsets. And 7 eliminates 3 here. So this is 1, 2, 4, which makes this a 3, 5 pair here. This is 7. This can no longer be 7. This adds up to 14. So this is either 5, 9, which is not allowed to be, or it's a 6, 8 pair. So this is 6 and 8. This is 7. This 6, 8 pair, it matches the 2 and the 4. So 2 and 4 have to be one of these, which means this has to be a 1. So this is 1, which means this cannot be 1 here. This cannot be 9 then. So one of these is 6 or 8, and this is 6 or 8, which eliminates 6 and 8 in the rest of the row. So this can't be 6 or 8. This can't be 6 or 8 because of the 6, 8 pair, or the 6, 8 in the column. These digits all see the 6, 8 pair, which must be different. So therefore, none of these can be 6 or 8. What digits can it be? It could be 2, 3, 4, 5, or 9. But 5 cannot be here. So this is 2, 3, 4, 9. One of the 9s must match one of these 4 digits because the 1 is there and the 7 is there. So 9 cannot be here. Similarly, 3 cannot be here because 3 must be one of the 10x pair subsets, right? Because 7 cannot be here. So this can't be 3. This matches then 2 or 4 here. So the other 6 or 8 must be one of these 2 digits. There also must be a 9 in one of these. If... You could have a 9 here. If this is 7, 8, this is 2, 3, and 1. That could work. Let's see. So this matches this set, and this matches this set. Okay, so the pink has to be... The other 6 and 8 is here, right? It has to be one of the pinks here, and it cannot be this one. So this pink must be one of these 3 cells. It cannot be the red one. So the pink must either be the blue or the green one. We're not sure which. These both see 6 and 8 because both of these are different again. It also sees the 1, 2, 4, 7. So this has to be specifically 3, 5, or 9 here. Okay. If this is 8 and this is 2, that would mean this could not be 2. So this would have to be the 4, 5, which means that would match with this orange, right? Because there would be no other place for this orange. Hold up. No. Other way around. If this is 2 or 4, that means the 6 or 8 here could not be any of these digits, and it cannot be any of these digits, so it would have to match the orange. So if this is 2 or 4 here, this is 6 or 8, and could no longer be any of these digits. And it can't be any of these, so then it would have to match the orange in column 1. So if this is 2 or 4, this matches the orange. If it's 6, then it would match the pink. Okay. What does that mean? I'm not sure. So this cannot be the blue. It's the other one. One of these two digits is a 9 because it cannot appear in the rest of column 7. 9 is also here. What are the remaining digits in box 3? They have to be 2, 4, 7, or 9. But this can't be 2 here. This can't be 4 here. This can't be 9 here. That's interesting. This also sees both 2 4s, 1 7, 6, and 8. Okay, where is this pink digit, right? This pink digit has to be one of these two digits here. This cannot be 1 2 4 6 7 or 8. So this is 3 5 9, but it can't be 3 because of the 3 in the row. So it's 5 or 9 here. Okay. If this is 6 and this is 4, how does this work then? It would have to be 1, 2, and 3 here. Well, okay. The minimum would be 1, 2, 3. You cannot. Okay, it has to be 1, 2, 3 because those are 4. You have to be 1 from each of the 4 10 pairs. And 6 takes up the 4 and 6. We need 1, 2, and 3. You can't have 1, 2, and 7 because 1, 2, 6, and 7 adds up to 16, and 4 with any single digit would add up to at most 13. So it would have to be, if this is 6, this would have to be 1, 2, and 3, but 1 can't be here. So this would be 1. This would be a 2, 3 pair here. This 1 means this would have to be a 9 here. This is 1, 2, 3, 6, which adds up to 12. Therefore, this would be 3 and 9 adding up to 12. This would then be 2, this would be 3, this would be 4 and 8. That actually works. Okay. Um, so yeah, that works. So if this is 6, this would be 4. You'd have 1 here. This would have to be 9. This would be 3, 2, 3, and 8. And that does work. If this is 2 and 8, um, this 6 would make this an 8. That would make that a 2. So that's fine. If this is 2 and this is 8, you can't add up to 10. Minimum would be 1, 2, 3, and 6 again, which is 12. So could you have 4 here? Hmm. Hmm. Um, okay, so that's that combination. So that we know that one works. What if we try to make this... Okay, so say this was 4. This would be 6. This would be 2, 5 here. Which means this pink would be 2 and 8, right? So this is 4, this is 6. Again, this 4 means this can't be 4. This is 2, 5 pair. This 4 has to match the orange because there's no other place for it. This blue can't be any of these. Can't be any of these, so it has to match the orange. So then we say we had this as 4 and this is 6, essentially. Again, so this is 4, this is 6, which would force this to be 6 and 4 because there's no other place for the 6 in column 1. This would then be 8 and 2. So neither of these could be 2 or 8. That's actually interesting. Yeah, we're trying this specifically so that, okay. So if this is 6 and 4 here, we know this is 8 and this is 2. The question, though, becomes, when is this ever 2 and 8 here, right? If this is 2, this is 8. That makes this is 6 and 4. 2 cannot be here. 8 cannot be one of these 4 cells. So one of these must be a 2, which makes this a 4, 5 pair. Wait, but we know that already. That's if this is 6 and this is 4, right? That makes this 8, 2, 6, and 4. So it's the other way that we want it, right? We want this to be... this to be 4 and this to be 6, which means this cannot be 4. This has to be 8, and this is 2. 6 cannot be here. We need an 8 in one of these, so there it cannot be here. 8's one of these, so this can't be 8. Therefore, this is 6. This must be 4. This must be a 2, 5 pair. 2 and 8 cannot be the red or the yellow, and it can't be the blue, so it must be the greens, which makes this 2 and this 8. But that's a contradiction because 8, so this only adds up to 8, and this already adds up to 12 with 2 digits remaining. So that doesn't work. So what we've proven then is this can never be 4 and 6 in these orange spots. It has to be 2 and 8. So this is 2 and 8, this is 4 and 6. This 8 means there's a 2 in one of these 4 cells, which means this can't be 2. This is a 4-5 pair. This is a 6. So 6 has to be one of these 2 digits. So we have 3, 5, 6, and 9 here. But this can't be 3. We now have a 5, 6, 9 triplet in row 3, which eliminates 5, 6, and 9 in the rest of the row. This can't be 9. Where is the 9 then in box 3? It has to be here. We also have a 2, 7 triplet, which eliminates 2 and 7 in the rest of the box. So this can't be 7. This is a 4, which means this can't be 4. One of these is a 9 because this can't be 9. This can't be 6 because one of these 2 has to be a 6. So this can't be 6. This can't be 4. We have a 1, 7, 8, 4, 5. So the remaining digits in column column 1 are 2, 3, 6, and 9. But this cannot be 6. It could be 3. 2, 3, 9. And these are 2, 3, 6, and 9. So this is 2 or 6. This is 4 or 8. It's fine. Can this ever be 2 and 8 is kind of the question, right? We've shown that we can have 6 and 4 perfectly fine here. So either way, this can never be 2, right? Because if this is 2, this can't be 2. If this is 6 and 4, we've shown that this has to be 2, 3. This is 1. This has to be 9, which makes this 3 and 9 adding up to 12, which makes this a 2, which means this can't be 2. So either way, this cannot be a 2. It's 3 or 9 here. This 3 or 9 matches with 1, 3, or 7 here. We're not sure which. Right? If it's 9 here, or this could be 9 also. 1, 3, 7, or 9. Kind of the question is, can this ever be 9 here? It can't be if 6 is here, but it could be maybe if 9, 2. But this could be 6 and 9 then. Red cannot be 4 or 6, so this cannot be 6 then here. So 6 has to be one of these 2 digits. And if you have it with a 9, 6 plus 9 is 15 already, plus 1 and 2 at minimum is 18, and 2 unique digits can never add up to that. Therefore, none of these could be 9 ever. So this must be then 3, this must be 9. This is now a 2, 6 pair here. This can't be 1 or 9. It cannot be 7 because, again, 7 and 9 add up to 16, and this would have to be exactly 7 and 9 to match up. So this is 3. This is 12. This is 11. This has to be 1 to match up. This 3 means this can't be 3, so this is 5. This is 9. This 5 and 9 eliminate 5 and 9 here, so this is 6, which means this is the pink, and this is 3. That makes this a 5, which makes that a 6. None of these can be 5. We have a 6, 8, and 9 triplet in box 5, which eliminates 6, 8, and 9 in the rest of the box. This can't be 6. This must be a 7, which forces this to be 6. Therefore, this must be the corresponding 10 pair, so this must be 4. And this adds up to 13. And you cannot have 9 there, so this is 8 and 1. None of these can be 8. This can't be 4 anymore. This can't be 4. This 6 eliminates that from being a 6, so this is 2 and 8, which makes this 6 and 4 to add up to 12. Oh, but we have 2 4s. That doesn't work. I'm guessing this is possibly incorrect here. Let's clear that for now. 2 and 4. This could be 4. This has to be 6 or 8, if that's the case. Wait, we have 6 and 6. How does that happen? Oh, okay. This is 6 and this is 5. Oh, that's the problem. This is a 5, 8, 9 triplet, not a 6, 8, 9 triplet. So there we go. I was wondering about that. Anyways, this was correct then. This can't be 4, so if this did become 2 and 8 and this is 6 and 4, that doesn't work. So therefore, this has to be 6 and 4, which makes this 8. Therefore, this is 6. This 8 makes that a 2, which means that can't be 2. This has to be an 8 to add up to 12, which makes that a 2. That makes this a 1 and a 9 to add to be in the same set. This is 2 and 8. So this cannot be contain a 2, and it can't contain a 4. We now have a 1, 5, 1, 5 pair in box 9, which eliminates 1 and 5 in the rest of the box. This can't be 5, this can't be 2 anymore, so this must be 4. Whoops. This must be 4 here, which means this can't be 2 or 4. It becomes a 5, 9 pair. These can't be 1 or 5, and it can't be 4. It's a 2, 6 pair here, which eliminates 2 and 6 from the rest of the column. This can't be 2, so it must be 7, which makes that a 2. Where is the 2 in column 2? Cannot be any of these cells because of this 2, so it must be here. So that's a 2, which means this can't be 2. Again, this must be 3 and 9 to add up to 14. Which means none of these can be 9. This can't be 8 because of that 8, so this is 5. Which makes that an 8. This 5 eliminates that 5, so this is 9, which makes that a 5. The 1 can only be here now. And we have a 4, 7 pair here. And we have a 7, 9 pair here, which is this 9 is limited by this 9, which forces this to be 7. That's 9. This is 4. This is 7. This 4 eliminates that 4, so it's a 5 and a 4 here. We have 3 and 8 remaining here. This can't be 8 because of that 8, so this is 3. This is 8. This 3 eliminates that 3, so it's a 5 and 3. The 5 eliminates this 5. We have a 3 in the corner, which we celebrate because we know we're close to solving it. This is a 1. This is a 5. This can't be 2 because of that 2, so this is a 6. This is a 2. I think that's all the 2s. We have the 6 has to be here, which makes that a 1. And we have 4 and 7 here. So this is 7, this is 4. We have 8 6s. So now the last 6, we know where it is. It has to be here. This 3 eliminates this 3. So this is 7, this is 3. We have 7 and 9 here, but this can't be 9 because of this 9. So this is 7, this is 9. That leaves this digit as an 8. We have a 1, 5 pair here, but this can't be 1 because of that 1. So it's a 5, a 1, which leaves a 5 here. This must be then a 7, and this is a 3. Yeah, generally, I guess it worked out pretty well. Combining the equal split lines and the Tentropy lines is kind of interesting. It restricts things in non-obvious ways, I would say. But they are still relatively simple once you understand them, I guess. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.